We discuss about the process of finding hardness of a material. First of all, what is meant by hardness? Hardness means the metal resistance to indentation is known as hardness. There are so many processes to find out the hardness, like Brinell's hardness test, Rockwell hardness test, and Vickers hardness test, etc. In all these, Rockwell hardness test is very easy to approach. First, let we talk about the Rockwell hardness test. Rockwell hardness test is similar to Brenner's hardness test, but in Rockwell hardness test, we find the hardness by measuring the depth of indentation. But in Brenner's hardness test, we find the hardness by measuring the area of the indentation. For a given load, depth of indentation is less for hard materials and more for soft materials. Hence, the hardness of material is inversely proportional to indentation depth. In Rockwell hardness, two types of indenters are used. First one is hard steel. It is of different diameters, 1/16 diameter and 1/8 diameter, 1/4 and 1/2 diameters. And second type is Braille indenter. It is made up of diamond in the form of cone and with included angle of 120 degrees and tip radius of 0.2 mm. During the test, loads are applied in two stages. First one is minor load. It is of 10 kgs. Second one is major load. It is of 60 kgs, 100 kgs and 150 kgs. We have to choose the weight, and these various combinations are of indenters and loads are indicated with the help of letters such as A, B, C. And we can refer in the table. It is a Rockwell hardness scale table. If the indenters are Braille, if Braille is an indenter of 60 major load of 60 kg, its scale symbol is A, and the dial is black, and its applications are hard thickness materials such as razor blades and cemented carbides. And another indenter is 1/16 ball. The scale symbol is B, and its major load is 100. Its dial is red, and its applications are aluminum alloys, soft cast iron, and cast alloys. And another indenter is Braille indenter, and its scale symbol is C, as its major load is 150 kgs and dial is black. Its applications are hard steels and cast irons. Another indenter is Braille of scale symbol D. Its major load is 100, dial of black, and medium case. Its applications are medium case hardened steels. And an indenter of 1/8 ball, and its scale symbol is E. Major load is 100 kgs, and its dial is red. Its applications are aluminum alloys, bearing materials, and cast irons. And another indenter is 1/16 ball of scale symbol F. Its major load is 60. Its dial is red, and its applications are thin components and annealed copper alloys. Another indenter is 1/16 ball. Its scale symbol is B. Its major load is 150. Dial is red. These applications are phosphorus bronze and beryllium bronze. Another indenter is 1/8 ball. Its scale symbol is H. Its major load is 60, and its dial is red. Applications are aluminum alloys and magnesium alloys. An indenter is 1/8 ball. Its scale indenter is H. Major load is 60. Its dial is red, and applications are aluminum alloys and magnesium alloys. And another one is 1/8 ball. Its scale symbol is 60. Its major load is 150. Its dial is red, and its applications are plastic materials. Indenter of 1/4 ball of scale symbol L, and its major load is 60, and its dial is red. Applications are plastic materials and vulcanized rubber. And indenter of 1/4 ball, and its scale symbol is M. Its major load is 100. Its dial is red, and applications are nylon and plexiglasses. 1/4 ball indenter of scale symbol P, and its major load is 150. Its dial is red. Its applications are soft materials. And indenter of 1/2 ball is the scale symbol is R. Major load is 60, and dial indenter is red. Applications are spring materials. As we coming to the procedure how we do find the hardness of a material by using Rockwell test. First, we have to discuss the diagram of the Rockwell test. It is a dial. It is used to check the values, to take the hardness values of a specified specimen, and the specimen it put on the anvil. It is anvil, and it is indenter which is penetrated into the specimen. It is a load selector. We can select the load 60, 100, 150 as according to our experiment. and it is the wheel. It is used for adjust the anvil height to it. The indenter is penetrated into the specimen, and this one is lever. It is used to apply and release the load on the specimen. Coming to the process, the specimen is placed on the anvil, and neither major nor minor load is applied. The anvil along with specimen is ready to touch the ball indenter, and with further increase a minor load of 10 kg is applied. A minor load of 10 kg has forced the indenter into a specimen with certain depth friction. By using a release handle, a major load of 100 kg is applied. In this 100 kg, it includes 10 kg of minor load, and additional 90 kg of load is applied. So total it's become 100 kg. After applying the 100 kg, because of the major load, the ball is forced into the specimen to additional depth, that is x2, without removal of minor load of 10 kg. Major load is removed, that is 90 kg out of 100 kg is removed, because of which some elastic recovery in the material occurs. Without removing the minor load, hardness number is read directly from the dial. After that, the minor load of 10 kg is removed, and next reading is taken on the same specimen at different places by the following process. The calibration of indenter is done by using the following equation. It is different for both braille indenter and ball indenter. For braille indenter, the finding hardness is equal to 100 minus depth of penetration in mm by 0.002. For ball indenter, hardness number equal to 130 minus depth of penetration in mm by 0.002. There are so many advantages for the Rockwell test. They are as the test includes both types of indenter. That is, we can do Rockwell test by ball type indenter and diamond type indenter, which combines advantages of Brinell and Vickers hardness test, and which eliminates their drawbacks. In Vickers, we can only use diamond indenter, and in Brinell we can only use ball indenter. But in Rockwell test, we can use both type of indenters, which can be easily find the hardness values rather doing Vickers hardness test and Brinell hardness test. And in Rockwell hardness test, the thick and thin materials can be easily tested, but whereas in Brinell and Vickers, it's not possible to find both the materials. There may be chance of breaking too. As the hardness number is directly available on the diet, the test is free from personal errors. But in Brinell and Vickers, we have to do the calculation. There will be chance of happening personal errors by the calculation. So it can be avoided from the Rockwell hardness test. And polished surface is not required because the hardness number is correlated with the depth of the penetration. But whereas in Brinell and Vickers, we need polished surface because we are dealing with the area of the penetration. But whereas in Rockwell test, we are dealing with the depth of the penetration, so we does not require whether the surface is polished or not. And it can be operated with less skilled worker too. It is easy to operate and easy to explain too. We can obtain the direct value, so it is easy to operate. The skilled operator is required for this experiment, and the testing time for this is very low as compared to other tests. There are parameters for Rockwell test. Principal is not measured, and we can apply load from 10 to 300 kg only. And time required for this Rockwell experiment, Rockwell test is very less. It is so easy to do, and operator skill is less skilled. An indenter in this test is used is steel ball indenter as well as braille indenter with made up of diamond. And surface of specimen is polished or not. It is not required for. It is not specified. It is not required to. Life of indenter is very. It is more. Notation is RC. Formula. As coming to formula, we can directly obtain on the dial. So we does not require any formula to calculate the hardness test. Applications are there are so many applications for this Rockwell test. It is used for finished parts like bearing, nut bolts, pins, cutting tools, electric contacts, etc. As compared to Brinell's hardness test and Vickers hardness test, Rockwell is very helpful and very useful. It is very easy to do, easy to find the value of the given material, you can be easily obtain. Easily obtain. It takes less time to do, and less skilled worker needed for it, not the higher ones. So Rockwell test is very useful than Brinell test and Vickers test.